So in this video, we're going to be finding the voltage drop across this 8 ohm resistor using Thevenin's theorem. But first, what is Thevenin's theorem? Well, Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source, VTH, in series with a resistance, RTH, where VTH is the open circuit voltage at the terminal and RTH is the equivalent resistance at the terminal when the independent sources are turned off. In essence, what Thevenin's theorem is trying to tell us is that if we add a linear network like this, we don't care what the structure of the network is, and it has two ports. Let's call those ports A and B. We can simply represent it with a voltage source in series with a resistance at these terminals A and B. So in order to solve for the voltage drop across this 8 ohm resistor using Thevenin's theorem, what we first have to do is that we have to make this circuit a two-port network at this point. And if we do that, we unplug this 8 ohm resistor and we have something like this. You see, it is just the same circuit but with the 8 ohm resistor missing. You can call this A and B. Then the next thing we want to do is that we want to determine the value of VTH. Now, determining the value of VTH can be done in several ways, but the method I'll be using here comes in two steps. The first thing you want to do is that you want to determine the current in this circuit, and doing that is very easy. You can just use mesh analysis. So if we call this our first mesh and this our second mesh, so mesh 1, mesh 2. So this current would be I2 and this current would be I1. We can simply say that I2 minus I1 is equals to 3. I2 minus I1 equals 3. Then we can write a Thevenin a KVL equation, mesh analysis KVL equation using a super mesh. And doing that, we would have so this mesh has I2, we would have 3I2, okay, plus 2I2 plus 4I1 minus 12 equals 0. We can solve these two equations simultaneously, and in this case we would have 5I2 plus 4I1 equals 12. So we can solve this equation and this equation simultaneously to arrive at the value of our currents. If we solve simultaneously, we would have the value of I2 to be equals to 8/3 amperes, and I1 would be equals to minus 1/3 amperes. With this knowledge, it brings us to the second step in finding the VTH, that is Thevenin voltage. And finding the VTH requires us, the next step requires us to just connect a voltage source across this terminal, and we label it VTH. Now we can just take a loop. Say we can take this loop and write a KVL equation in the loop. Don't forget that we already know the current flowing through this resistor, and the current flowing through the resistor is I2. that is 8 over 3 amperes, and we can just write a KVL equation there. Writing the KVL equation, the current flows in this direction. So we come like this, and we have VTH minus 12 plus 3 into 8 over 3 equals 0. If we expand this, we have the VTH is equals to 4 volts. So we have the value of VTH. The next thing we want to do is that we want to find the value of RTH. Now, finding the value of RTH is not a problem. All we just want to do is that we turn off the power sources in the circuit, the independent power sources in the circuit. So we turn this one off and we turn it off. Then we find the equivalent resistance. Now, when we turn a current source off, an independent current source off, it leaves an open circuit. And when we turn a voltage source off, it leaves a short circuit. Now, we are going to go ahead and redraw the circuit, redraw what the circuit looks like when we turn it off, and it will look something like this. We have 3 ohms, then a short circuit, it comes here, then we have 2 ohms, then we have an open circuit, then we have 4 ohms. The circuit will look something like this. After we turn off the power sources, then these two are in series, so that will be 6 ohms, and then they are in parallel with this, so in parallel with the 3 ohm resistor. And when we resolve them, RT would be equals to 6 times 3 divided by 6 plus 3, and that would be 18 divided by 9, 2 ohms. So RTH would be equals to 2 ohms. We can then go ahead to draw the Thevenin equivalent of this circuit through these ports. And doing that, we would have something like this. So we have a voltage source in series with a resistor and a port A, a port B. Then we have plus minus. VTH is 4 volts, 4 volts. Then RTH is 2 ohms, 2 ohms. Then we can go ahead and plug back our 8 ohm resistor in the circuit. You can plug back our 8 ohm resistor in the circuit, 8 ohms. Then we can easily find the voltage across the 8 ohm resistor. And the voltage across this 8 ohm resistor using the voltage divider would be 4 equals 8 over 2 plus 8 multiplied by 4, and that would be equals to 3.2 volts. And that is how you use Thevenin's theorem. Thank you for watching the video. Don't forget to hit the like button and subscribe. See you next time. Bye.